Good afternoon.
Good afternoon, sir.
Okay, very
Good afternoon, sir.
now just because there's some official work, therefore I have to go for 15 minutes before it happens sometimes. I'll try to finish by 1:10. Maybe give you take 15 minutes time today. Now in the last class, we have done conversion from infix to postfix and also done that evaluation of postfix. Now this postfix is also that is called also called reverse Polish notation. These are called as reverse Polish notations. Now, just going with that, the algorithm was too simple. Uh, what I what I did on that day was to take expression and convert it to a postfix. But if you can see the algorithm, it's quite simple. I'll just, if you want, I can write it down. But it's not that difficult. What you will do is that you have to scan. You have to first of all put a right bracket at the end of the expression, and then you have to scan the infix expression from left to right, character by character. If you find that uh, if you find that you have already got a left bracket, push it into the stack. If you find that's an operand, you put it into the expression. If you find the operator, then you do two things. First, pop all the operators having equal or greater precedence from the stack, and keep on adding into the expression. And after you pop all, you push that operator which you found in the stack. If you get the right brackets, keep popping all the operators from the stack and add it to the expression until you get the right bracket. The moment you get the right bracket, sorry, you get the left bracket, you take that left bracket and discard it and keep on running until the stack is empty. Now, obviously, once you find that the stack, when the expression, end of the expression is found, you will find that the stack has to be empty, and that is a condition that your infix expression was correct. Now, in case I am not going to use the, in case I am writing a wrong expression, I will get either an underflow, or you might find that there are some extra brackets or operators inside that stack. Now, if the expression is having an extra number of operators, you will find that the stack will not become empty, and you will have some operators inside that. If you find that the extra number of brackets, it means that your expression was not balanced. And these are the ways you can do in order to make sure that your expressions are there or not. Now I already told you there are some variants for this, and you have to keep on exploring that. Now today I will also discuss one of the algorithms which is there, which is that is I'll discuss convert infix expression to prefix. I'll write expression to convert an infix to prefix. Now prefix, just to explain it, prefix comes with operator, operand, and operand. Then operand 1 and operand 2. That means the operator will come before an operand. That means if I have a simple like this, say A plus B into C, you will first do this one plus AB, then into C, then you will say this into will come here, because this multiplication sign will move from here to here, and therefore it will be into, now obviously the precedence and the bracket is already taken care of. Now this is also a bracket free and a precedence free expression. Now this is the prefix, and that this is precedence free and bracket free. Now, what we have to do is that we have to develop an algorithm to convert an infix to prefix. Though I tell you, postfix is mainly used at all places, but you might find a prefix somewhere in the case of computer science. Otherwise, normally we work with postfix expression form. Now let us try to develop an algorithm for this. Now once I am going to write now the program, if we will start with the data structure labs, maybe after some time, we'll end up in finding that we'll be able to run the right algorithm program for this in C or C++ language. Now let us find the algo. Prefix. Infix. Now suppose you are given some input expression, You are given some input expression. Anything, I'll not take an example, but I will try to show you. Now I have taken plus, minus, divide, multiply, as well as the power exponential. Therefore, this is not e power of f. Now, this is the input expression in the infix form, and what you will do is that you will convert it into equivalent prefix. Now, the first step, I write the algorithm first, and then show you that running this algorithm on this input expression will achieve that result. Now, first of all, what I will do is that I will reverse the expression. I will reverse the input expression. Now this is the expression which I have to reverse it. Reverse it means now from right to left it will be f exponent e slash, but the brackets has to be maintained like that. That means you are not going to, the bracket has to be over there. Therefore d minus c will come, but the bracket will remain as it is. I do not mean to say that you will have a bracket like this. Not like this. The bracket will be here only, whereas c minus d will become d minus e. If I having a c minus d like this will become d minus e. Does not mean that you are going to reverse this one also and reverse this one also. This is not required. Okay. That means you are going to just reverse the expression such that the brackets has to be maintained like that. Now after that you are going to do. Now you start with the things. Second. Now again, what you will find only four things: either operand or operator, or left brackets or right bracket. Now this will be the same in both the cases. It will be same. Now, if an operand is there, if you find an operand, what you're going to do in the previous thing is that you are putting it in the cap. You add to the expression. Add to the expression. Same thing, operand will always come in the expression. Then, if you are going to find a closing parenthesis, that will right parenthesis. If we find a right bracket, that means the closing parenthesis. Now, what we are going to do is this: we are going to push it in the stack. We'll push it into if you find a closing bracket, we are going to push it into the stack. To remember the last algorithm, if you find the left bracket, or the opening braces parentheses we are going to push in the stack, but here we are going to push the closing parenthesis in the stack. Now fourth one, if we get an operator,
सर शशि कलवाल लेफ्ट हो गए, उसे आप ऐड कर लीजिए.
उसको
शशि कलवाल सर.
so why do you require for adding? You're not able to hear this? There's no request for this. I'm not getting you. What's the problem? Rishi Talba is not being able to access this?
सर कोई प्रॉब्लम आ रही है, इसलिए वो ज्वाइन नहीं कर पा रहा, पता नहीं क्यों.
Sir, I think you have to click on the tick mark.
Oh, he has to just he has to join this code and then tell him to join. I will be able to add him, but there is no request for adding.
ओके सर, ओके.
Because if you will get a request, I'll join it. But once I am in that presentation mode, it doesn't that window is not there. Therefore, that might be able to. I might not get in the message that somebody wants to join. Normally, if you join one time, it doesn't take another time. But okay, tell him I'll just check it out. If I get a request, I'll join from the other system.
Sir, there is a tick mark button. I think you have to click on that.
Which mode?
Please go to the window. Yeah, there it is. The tick mark button beside beside the video.
Something else. I think this is for phone, joining by phone. This is show hide attendance screen. This is another one which is not there. Right?
It's okay, sir. We're late as is.
Huh? Is he there? No.
I said we're late as is.
You tell him to join with another email ID. I will permit him today. There's no problem. There's no issue. I can join with another email ID. Now, if you get an operator, they have to do two things. One is that first of all, you have to do an A. If the stack is empty over there, push operator in the stack. If the stack is empty, push operator in the stack. Okay. B. Now, if you are going to, if it is a closing parenthesis, now in that case you will find. Then, if the top of the stack, if on the top of the stack, TOS stands for top of the stack. If on top of the stack you find that it is a closing parenthesis, if is a closing parenthesis, then you have to push the operator in the stack. Then push operator in the stack. Okay, that means the top of the stack as an thing which you have to push in the stack. Then C, now you have to do is the if the operator is of higher or same precedence than the operator on POS, in the then push operator on the stack. Then push that means if it is having a higher or same precedence than the operator on the top of the stack, then push operator in the stack. Okay, T. Now that will come the S part. If it is not, all this is not there, then we have to do is that pop the operator and add to expression. And then to that operator which you have found, then push the lower priority operator in the stack. Now I'm writing in expanded form because I did not write the last algorithm. If I'm writing in the expanded form, all the cases are there. No, it does not mean that all these 5 cases will come. You will get only 1 or 2 of them. That means sometimes you will have to push this there, obviously it will be there. Either one of them will be there. Either it will be A or B or C or D, E will always be there. Now, the fourth one, I think last is the fourth point. What remains if we find the left bracket. What you do is that you now he has come. Pop the operators and add to expression until we get okay? That means if we find this, what we are going to do is that we will first of all take that, you will keep on popping the operators and keep on until adding to expression until we get the closing parenthesis. And after that, when if we keep on doing when till there is no more expression to come, or you can say that when we find the sentinel value. That means I have not written over there, but I can say that if no input if no input is there, that means pop all remaining operators and add to expression. Now, till now we have what we have got an expression, but the final step is also there. The final step I just write in different color pen. Now, once you get that expression, this is not the answer. The answer is that you reverse the expression to get the desired prefix. And here I stop. Now this is the algorithm. Now what you have to do is that try to apply the same algorithm on the previous one and try to get whether you get this now. Now if you are going to just, I'll show you. If I take this expression over here, let me see what is the output manually, and then using that we will try to do that. What is expression was this. Now, once you are going to do it left to right scanning, there are two brackets. This is the first bracket and this is the second bracket. But at a time, you can only do the first one. Therefore, this A plus B will become plus AB. Now, when you do the second time, you will do this minus CD. Then third time, there are multiplication, then divide, then power. Which is having the higher precedence? Obviously, you will have the power. Therefore, in that case, what you do, you are going to do this one, and this will become this. And then you are left with two operators. One, this one. Now you are left with two operators, one this one and one this one. Now this will be done first. Therefore, this will be multiplication plus AB minus CD. And obviously this will be copied as it is. And then you will do this one. This will come at the first, then it will like this. And this is the final expression. If you are going to fill, this is the final expression. And running the algorithm, you should be able to get this expression. That is the perfect expression. You will be getting this expression if you are running that algorithm. Now you start with this. I'll just give you. Then you should try at home. You first reverse it. This will be F power E slash the bracket D minus C, and keep on doing. And then you will start applying the algorithm. And this is the how you are going to convert an infix to prefix. Okay. Now you take one thing. Now if you are going to see the book, what it happens, you will take the entry string, the input string, and then try to see which character it is found, and then what is the equivalent prefix, and then if you can make a table out of that, you might make a table like this. and you take, and here you are going to take the what is the status of the stack. Then you can take the character which we found and keep on doing like this. And this is the what is the actual expression you are getting. The actual expression you are getting. And then you find one character. Suppose I get say F. You are not going to push into stack, therefore it will be F in the expression. Then I get the power sign. I will be, you have to, now in the second time I get this power. Now in that case you have to push in the stack. Suppose you have to, then this will come here like this. Then you get E. What you do is that the stack will remain same and this will be F. Okay. Now again, when you find the bracket, now let us I just show you. When you find the bracket, you will get this will become F, E, and power. Right? Once you get a bracket, you pop it out. Now when you pop this power exponent sign, if you come over here, this will get Fe plus. The Fe with the power sign. But at the last step, you remember that I was going to reverse it. Now once I reverse it, it will become something like this. Then I reverse this, reversing. And you find that this is the same as this one. And therefore, I got the same over there. Similarly, if you keep on doing, all these ones will come. That means you keep on doing all this. How many characters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now this will be, we have to do it 15 times over here. This is a manual way to verify whether the algorithm what we wrote is correct or not. Any questions?
Excuse me, sir. The work which you had given in the previous class, that to check whether the infix expressions is balanced or not. Sir, I have not done that, sir. I have just done the parenthesis balancing.
Okay.
So I have confusion on that.
What we are trying to do is that we try to find that majority of the students should actually respond that if they have done or not. Now, if they have not done, it's okay. They can try at home. But we find that if we get some people are there who have a combined doubt, we'll discuss in the class. If we find that few people are having, 1 or 2 people are having individual doubts, we'll do it on a one-to-one basis. Okay. Now we expect that people should run that, try to learn on their own. They come with problems and they discuss over here. If you have a common problem, we'll discuss in the class, and after the class, we have enough time to discuss that. Okay. No problem. I will be able to solve almost all your problems. Okay. In this case, if you are going to, even if you are going to send the coded file for that, I will try to remove those errors and try to correct the codes and try to send you back on your emails. Therefore, but slowly you have to start writing. I don't expect that you are going to write a program for this. It will take some time for developing. At least in this week, I try to show you that writing all those programs and compiling it, and then trying to do the one class which I have to do. I'll take it. Now, I will come with the second application of stacks. Now, till now, what we have been doing, conversion from postfix to prefix or infix, are all those conversion ones. Therefore, conversion from infix to postfix, evaluation of postfix, conversion from infix to prefix, or evaluation of prefix, and all those are there, which are one type of application. Second application which we are going to do today is a very, very important application, and what we call it is recursion. Now today we'll discuss the recursive algorithms and tell you that how the recursion works internally. Now, most of you might be knowing that recursion is a way by which you call the same function inside its own body. if I am going to call the same function inside its own body, it's called recursion. Now, very simple, it could be something where I am going to write like this. And if I have some function f calls with some parameters, say with parameter x, and I have some function, say int function, and then we say if I have say int, say t, and I call somewhere here again this with some different parameters, with some parameters. Then I can call that this function is a recursive function. You can see that this function is a recursive. And this process is called as recursion. The process of calling a recursive function from somewhere is a recursion. Now here, it is not that all functions recursively will work like this. There are some preconditions that whether the recursive function is valid or not. Now there are basically two main reasons. Once, therefore, what are the requirements? First of all, it must have a terminating condition. Terminating condition means it should have condition by which the function must terminate. Otherwise, if the terminating condition is not there, the function will run infinite times. Therefore, the terminating condition has to be met. If I just write like this, what I wrote is not practically correct, because before this calling this function again, you must have some if condition. Therefore, actually, it should have been something like this. So if some conditions might be there, then I will call this. When I will have else, I will have some other thing. I will say else. I might have say else return, say some value. Say I say t. If I say t. Now this could be correct if I am going to put correct conditions and a correct thing. Now this is the one. Therefore, the conditions must be there. Now, if condition is achieved, if it is true, if this is true, go inside and call it again. If it is false, then it will just return. And since I am returning an integer value, it is going to return temp. Now, I have to manipulate temp and put some data into that. But the meaning is that there must be an else condition. Otherwise, the function will run in infinite times, which happens. If you are not going to implement a recursive function correctly, it is going to run in infinite times. And the second condition is that all recursive calls to this function must lead you towards the solution. All further calls should bring near to solution. All further calls should bring it near to solution. That means when I am going to call it with some value, say if I start a function with t value, the next condition should such that it should bring it near to the solution. Suppose I start with x equal to 5. It should become x equal to 4, then 3, then 2 and 1. If 1 is there, the condition must be met. That means every call to this function must bring it nearer to the goal and near to the solution. Otherwise, any of these two conditions is not fulfilled correctly, it will always make the call an infinite call. You always make it infinite. Now, once you're going to implement these two correctly, the best part is that the recursive functions can do wonders. Why? Because greatly decrease the length of the codes. Will greatly decrease the length. I will be writing 3-4 algorithms to show you that why recursive algorithms are so important and so useful in some cases. I don't mean to say that all problems can be solved using recursion. There are very few problems actually which you can do in recursion, because if you cannot convert those problems into these requirements. That means you cannot make the requirement such that those solutions can be found at. For example, I want to add two numbers. I cannot write a recursive algorithm for this, a recursive function for this. But let us try to do one of the very, very important concept. Let us try to write an algorithm. For example, algorithm, which is a very common algorithm which most of you have written in the last semester, to find the factorial using recursion. Now, if I am going to write a simple algorithm factorial, I am just doing it a very simple one. Now, if you are going to write an algorithm for factorial, just write like this. Let me write a non-recursive one. This is a simple function. I have written a factorial function and called t with 5. Now I am going to write the recursive function for this. And write say integer, a fact, now this is a recursive function I have written that in fact integer x, if x equal to 1, return 1, else return x into fact of x minus 1. Now these two functions combined is a recursive call function. Now here fact is a recursive function, and this process of calling this fact from main is recursion. Now here you find that whenever you are trying to do a factorial problem, it is a looping problem. That means if I am going to find a factorial of 5, it is going to do say 5 into 4 into 3 into 2 into 1. That means the multiplication must be done 5 times. It should be done 5 times. That means it's a loop problem. For I is equal to 1 to I less than 5, then you are going to multiply that number with x, keep on doing 5 times. It is going to now, what are you doing like this? You write it like this: for I is equal to 1, I less than say 5, I plus, I will write say answer is equal to answer multiplied by I. And then after that I will be getting the answer. After 5 times I will get the answer. Now this is a non-recursive way, but you are looping by. Now here this loop will run say 5 times. But when I say that this recursive function which I wrote over there, there is no loop. but if it will be same as the 1. Now let us try to analyze how this function works. Now let us start here. You are going to put t is equal to 5, and here the value of t will become 5. Now this is a calling by value, therefore x will get the value equal to 5. Because you are passing the value, now t is going to pass over there, and 5 will be copied to x. Now if x equal to 1 is false, therefore it will come to the return type. Now here, when it will come to return type, it will become like return. Now try to analyze. We will say 5 into then fact of 4. Become fact of 4 because x minus 1 will become 5 minus 1, and this will give you 4. But it will not return because before returning there is again a call to fact. Therefore, once it finds the value 4, it again calls the function inside. Now in that case, again x will get a value equal to 4, and will again check is 4 equal to x equal to is 1 is false. Now this will again translate to 4 into fact of 3. Because it will say return 4x is 4 into fact of 3. Similarly, the next time this will come, this will again call the function again, and it will be able to give you that now this will say 4. This will be say 4 into fact of 3. We'll call this one as 3 into fact of 2. Similarly, again this will call 2 into fact of 1. Now here you find that x has now become 1. And now when you come to the top, you find that x is equal to 1 is now true. Because here, this is the value of x. Now this one, x is equal to 1 is now true. And therefore, it is going to get a return. Now one thing what I am not writing is that when I am writing this is also is there like this 5 into return like this. Because fact 4 says return x into fact of x minus 1. Therefore, fact 4 will say return 4 into fact of 3. Similarly, over here, when it is here, it is also having return over here also. Similarly, there will be return here also. And therefore, it is nothing but return 5 into return 4 into return 3 into return, then 2 into, then return 1. Now, how many times they return? It will be having a return over here, they will return over here, return over here, return over here, and this will also return 1. Now, this will return 1. That means this will return, say, since the value 1 is there, therefore there is a 5, this is return over here also. Now, if you are going to check it out, actually you are having, say, you will have 1 return over here, second return over here, third return over here, fourth return over here, and 5 return over here. Every time it is returning a new value of x, but here it is returning 1, which is nothing but a constant. Therefore, what will happen? Return 1 means 1. Therefore, now this will be replaced by 1. And in the previous return, it will be 2 into 1, which is nothing but 2. Therefore, this will be returned with 2. Then it will be 3 into 2, which is nothing but 6. Therefore, it will return here it will return 6. Then in the previous, now 6 into 4, you already have returned with this. Therefore, now this will return over here, it will return 24. Then this will return over here as 24, and then 24 multiplied by 5 is 120, and this will ultimately return to the calling function as 120. That means this return will ultimately return 120 back to the calling function, and therefore now here answer will get the value equal to 120. Because the return has ended, there was return and there were internal returns. There were internal returns, and once the final return is going to come, it is going to return answer is equal to 120, and here the answer will be printed as 120. The print answer is equal to 120, and therefore I will be getting the answer is equal to 120. And if you understood that concept, you know that the return is 5 times. There is no loop as it is like this, but even this is going to loop inside. It's going to loop inside, and the loop is now actually the whole will be like interpreted like this. If you interpret like this, let me show you. If you interpret like this, return 5 into return 4 into return 3. Now this is the whole one. Now this is, you find that it's one time. If I'm just taking it like this, 1 time, 2 times, 3 times, 4 times, and 5 times. And this is going to return 1. Therefore, if you say return x, it will return the value of x. But here it is nothing but return 1. Then what is happening when I am saying that it is going to return over here is 1 value? It means that I am returning 1. Return 1 means returns a value 1. Therefore, here this is going to return a value 1, and this becomes 2 into 1 is 2. That means it will be like this is one bracket more. Actually, when you return 1 is there, therefore this will return 1. This is replaced by 1. Then return 2 into 1, this will be replaced by 2. Then return 3 into 6, this will be replaced by 6. Then return 6 into 24, this will be returned by 24. And then return 5 into 24, this will finally return to main the value 120. Okay. Now, if you understood this, one thing which is very important, which I want to ask you, that if I am going to, where I was storing the value of 54321, because once you start a program over here, now let me show you. Once I am going to write this program, now x is, there is only one variable x. Now here, let me show you, there is one variable x, which contains the value equal to 5 initially. Now once another call to this function comes, you get the value of this to x minus 1. That means you are changing the value of x to x minus 1, which is 4. Now what will happen, once you are going to do this, you are going to erase this value of 5 and write it equals 4. Again, with a further call to this function, this 4 will be replaced by 3. And you have lost 5, you have lost 4, you will lose 3, you will lose 2. Now the question comes, if x can only hold one value, where are these values 5, 4, 3, 2? Because once you return it, once you are going to return from here, once you are going to return from this place, you find that I have the previous value of 2 multiplied by factor of 1. Now where is that value of 2? Because you have only one variable x. This fact function only contains one variable. Now where is this value of x? Previous value of x. That x is having a value 5, then 4, then 3, then 2. Obviously, It is already maintained in an inbuilt stack. And therefore, what happens, you have to understand from the point, it's already maintained a stack like this. The moment the function makes a recursive call, the value of 5 is stored in the stack. Again, when it calls with return with a fact 4, 4 is stored over here. Again, when it is called with a fact 3, 3 is pushed in the stack. It is not pushing all those values. Similarly, it will push 2. Now, when fact will become 1, it will not push 1, but will return 1. Now, once a return will come, now here it will return 1, and this value will pop out from there, and it will say 2 into 1. Then again, next return will come, it will pop this value here, and will say 3 into 2. Similarly, it is going to pop another value over here and say 4 into 6. And the last time it is going to pop the value over here and say 5 into 24. And this return value, which is the last return, this one is going to return the last value of here. And therefore, this method of making a stack is automatically done by the compiler, and you are not concerned with this. Therefore, it is done automatically. This is automatic. And we are not concerned with how to maintain the stack and how to put those values. Therefore, I told you in the very earlier classes that only those languages which has a facility to maintain the stack supports recursion. You can do in C or you can do in C++, but if you know the other languages like Fortran or BASIC, you cannot implement recursion because those languages do not support the maintenance of the stack. But of course, if you want to do it from your side, that you maintain the stack and keep on pushing every time the old value, you can make such type of programs yourself. But the onus to maintain the stack will lie upon you. The onus to maintain the stack, to make the push and pop, has to be done by you. That means you have to again write a function of a push, a pop, and then you have to use an array to declare this, and you can do any way. That means to implement recursive function in those languages, you have to write extra functions for push, pop, and declare array and so on. But in C programming, this is done automatically by the compiler. Therefore, we say that C supports recursion, Pascal supports recursion, C++ supports recursion, but Fortran and BASIC do not support recursion. And therefore, recursion is one of the very important contribution when you are having a stack. Now, sometimes you have to maintain the stack yourself. Sometimes the compiler will automatically maintain the stack. And therefore, this is the second applications of the stack, is that recursion, all recursive functions, wherever you are going to do, we'll be going to do that. Now, tomorrow we'll do some of the functions. Like this, we'll try to have a problem. We'll discuss the problem of what? We can discuss function of Fibonacci series. Then we can discuss the problem of the greatest common divisors and some problem which will come in the later part of the chapters. We can discuss these problems, which are very classical problems of we can solve in recursion. And you're surprised to know that Tower of Hanoi is one of the very, very classical problem of this problem can be solved in only 3 lines using recursive problems. A non-recursive algorithm will take at least 50 to 60 lines of code. A non-recursive algorithm to implement Tower of Hanoi will take 50 to 60 lines of code, where a recursive algorithm will hardly take 3 lines of code. But the overhead is on the compiler. The overhead to maintain a stack and is on the compiler. You just write a 3-line code to solve the problem, but the compiler has to maintain all these things. And therefore, we'll discuss 3 problems tomorrow. Maybe there are a lot of problems you keep on asking, and then we'll be able to solve those problems. For example, I might write a Fibonacci series, which is an extension of a Fibonacci series, and therefore we can keep on doing a lot of problems. Now, again, the problem which we'll discuss in the latter part of the thing, we'll not discuss tomorrow, is the problem of, say, all those problems, which is a very important algorithm you might know. The Quicksort. Sorting algorithm of Quicksort, and a very, very good algorithm of sorting. This also works with the recursive function, as a recursive function for this. That means Quicksort can be solved using recursion. And if you can solve this, well, if I want to do selection sort, I cannot do using recursion. Or I want to do a bubble sort, I cannot do using recursion. Therefore, I do not mean to say that all functions can be translated to a recursive function. But the Quicksort can be done. Because the way to how you are going to do, now this will work on a principle called a divide and conquer principle. Works on a programming paradigm called as divide and conquer. Divide the problem and apply the same algorithm on both the parts. Then you again divide it again further, again apply to both the parts. Now here we say that once I am going to divide this, I am going to make the problem smaller and smaller. Now let us try to just finish in 2 minutes. If I am going to use, let us take an example. If I say, if this would have been a shape, if I had written x plus 1. Now the conditions are fulfilled. One condition, the condition which was there is that, the condition which I wrote is that it should have a terminating condition, this one. Which is true, it has having a terminating condition. And if you find over here, the terminating condition is if x is equal to 1. Therefore, this condition is terminating condition, which is true. The second condition is that it should lead towards the goal. It should lead towards the solution. Now, if I am going to write x plus 1, what will happen? It will start with 5, then 6, then 7, then 8, 9, 10, 10, infinity. And fact of x plus 1 will keep on calling this function infinite times. And therefore, the second condition is not fulfilled. Is that it should bring you near to the goal. And therefore, if you write x plus 1, the second condition is violated and you will not be able to achieve the results. Whereas, if I am going to write minus, that is fulfilled. And therefore, this is the one which I wrote over here was wrong. Actually, this should have been now this will be, say here it will be plus minus 1. And with a minus 1, you start x equal to 5, then 4, then 3, then 2. Ultimately, when it reaches 1, which is nothing but this value, and therefore at this point it is coming near to the goal. Therefore, you should start from here, keep on converging when it reaches to the goal. Where it should not be like this, where you start with a value and then keep on diverging and it comes to infinity. Therefore, with a one small mistake, you may not be able to achieve the result because the condition number 2 is not fulfilled. And therefore, once I am going to do this algorithm, you have to make sure that both the condition must be fulfilled. Okay. Now, any questions?